A reversible heat engine receives 2 kJ of heat from a reservoir at 1000 Kelvin and a certain amount of heat from a reservoir at 800 Kelvin. It rejects 1 kJ of heat to a reservoir at 400 Kelvin. The net work output in kilojoule of the cycle is, the given options are option A 0.8, B 1.0, C 1.4 and D 2.0. So before we solve the given numerical, let's briefly understand the statement of the given numerical as per the given data. And this we understand more clearly with a diagram. So let's draw a diagram of heat engine. So let's say that is a heat engine, and the heat engine receives 2 kJ of heat from a reservoir at 1000 Kelvin. So let's draw a reservoir having temperature 1000 Kelvin. So from this reservoir the heat engine receives, that is Q1 amount of heat energy. Let's say it is 2 kJ as per the question. And again it is mentioned that in this question that the heat engine receives certain amount of heat from another reservoir having temperature 800 Kelvin. Let's say that certain amount of heat energy, that is Q2, which is received by the heat engine from the reservoir having temperature 800 Kelvin. It is also mentioned that the heat engine rejects 1 kilojoule of heat to a reservoir at 400 Kelvin. So let's say this is a reservoir having temperature 400 Kelvin. So to this reservoir, the amount of heat energy that is rejected, let's say it is to be Q3 is equal to 1 kilojoule. So by referring this diagram, let's write down all the data individually. So Q1 is equal to 2 kilojoule. Q2 is not given. Q3 is equal to 1 kilojoule. Simultaneously write down the temperature. Let's say T1 is equal to 1000 Kelvin. T2 is given, that is 800 Kelvin. T3 that is equal to 400 Kelvin. Now the question arises that what we are going to calculate here. So that is the net work output of the cycle. So it means the work done by the heat engine. Let's say that is W. So W we are going to calculate here as the net work output of the cycle. Now as this is a case of reversible heat engine, it means the heat engine operates in accordance with the second law of thermodynamics. Now as this is a case of second law of thermodynamics, it means here we are going to use the principle of Clausius inequality. Clausius inequality is a key concept in thermodynamics that provides a mathematical statement of the second law of thermodynamics. So according to the Clausius inequality, it is cyclic integral of dq by t, that is less than equal to 0. So if we consider the expression for reversible heat engine, it becomes cyclic integral of dq by t, that is equal to 0. The symbol cyclic integral is used to indicate that the integration is to be performed over the entire cycle. and any heat transfer to or from a system, that is heat engine, can be considered to consist of differential amounts of heat transfer, and the cyclic integral of dq by t can be viewed as sum of all the differential amount of heat transfer divided by temperature at the boundary. So, according to this expression, we can consider this as Q1 by T1 plus Q2 by T2 minus Q3 by T3 is equal to 0. So here in this expression we use minus Q3 because this Q3 is the amount of heat energy which is rejected by the heat engine. So now we have to put all the values or all the data which is given here to this expression. Let's substitute the value of Q1 to be 2 kilojoule, T1 is 1000 plus Q2 that we don't know, keep it as it is, T2 is 800 minus Q3 that is 1 kilojoule by T3 that is 400 Kelvin is equal to 0. So now see, here we have substitute all the values and Q2 is the only term which is left here. So if you solve this expression, we get the amount of heat energy received by the heat engine from the reservoir having temperature 800 Kelvin. So that is Q2 is equal to 0.4 kilojoule. So after solving the above expression, we get the amount of energy that is received by the heat engine from the reservoir having temperature 800 Kelvin is 0.4 kilojoule. So in this question we have to find out the net work output by the heat engine. So for that we have to use the energy balance equation. So from energy balance, we can say that Q1 plus Q2 is equal to W plus Q3. So here we can say that Q1 to be 2 kilojoule plus Q2 that already we calculated, that is 0.4 equal to W plus Q3 that is given 1 kilojoule. So if we solve this expression, we get the amount of W that is equal to 1.4 kilojoule. So this is the final answer. So as per the given option, we can say that the option C is the right answer for the question. So I think it is clear how we use Clausius inequality for the given question. Thanks for watching. See you in the next video.